Welcome to Computer Vision Channels. I'm your host Anton, and today we continue exploring different DeepStream plugins. Today we will learn what is GStreamer NvDSPreprocessor, how to use it, and we'll take a look at a couple of details of the implementation. First of all, if you look at the documentation, GST NvDSPreprocessor is currently in alpha version, but it's still quite stable, and there are a couple of even sample applications with it. So the idea is that we will receive batched GST buffer with some metadata from previous elements, and then we will process those images and convert them to NvDSPreprocess batch meta. NvDSPreprocess batch meta is a special structure that will contain already prepared tensors for our NvInfer model. And we will need to change NvInfer configuration to accept input as tensors. And those tensors are already preprocessed and normalized. There are two ways to modify NvDSPreprocessor. First is to use directly NvDSPreprocess library and add the custom level code on this level. Or we can also access to open source code of NvDSPreprocess and modify the code on NvDSPreprocess level if the interface provided by custom shared library is not enough for our use case. In addition to this functionality, as always, NVIDIA will put a couple of additional functionalities that will make modifications and reading of the code more difficult. There is a notion of streams, groups, and regions of interest. So we can create in our configuration file multiple groups, and for each group that could be assigned to different number of streams, we can create a region of interest that will be processed and converted to NvDS preprocess batch meta. But those are a little bit complicated details. Let's take a look at the first example, how we can change the default preprocessing, the default rescaling of NvInfer to NvDSPreprocessor. We are starting with our common simplest example with NVURI source bin and default video, NvStream MUX, and NvInfer with default configuration. After compilation, we will see the detections of objects, of vehicles, and of pedestrians. So what we need to do in order to switch from NvInfer to NvDSPreprocess plus NvInfer. We need to add NvDSPreprocess plugin to the pipeline and create a preprocess configuration. For NvInfer, we need to switch to input tensor meta. So NvInfer will directly take tensors that will be already on GPU memory and feed them directly to the neural network for inference. For how to create NvDS preprocess config file. First, you can take the default example from these sample pipelines. Then you will see multiple parameters. Next, you need to check your config primary parameter. And the most important parameters for rescaling will be a net scale factor, will be a model color format, RGB, BGR. It will be also dimensions of the inference and we will need to add the input tensor meta, but we have done it inside GST launch command. So here we don't need to modify this configuration file. So our main parameters will be network input shape. That should be of the same size as the expected input tensor. Network color format, in our case RGB. And other parameters to be used by default. Pixel normalization factor, it will be our net scale factor. And if we have mean offsets, they will go to the offsets or to the mean file. Next, we just need to make sure that our source ID will be in some group. And in our use case, we don't want to use region of interest. We want to process the whole frame. After that, we can go to C preprocess, build. And we will see that we have our pipeline with NvDSPreprocessor and input tensor meta. And we have the same detections because NvDSPreprocessors implement the same resizing and transformation functions. So next step is to maybe modify it in a more complicated way or implement some custom tensor preparation and transformation functions. Let's dive deep into the implementation of JST NvDSPreprocess. For that, we can connect to the running Docker container, go to sources, JST plugin, JST NvDSPreprocess, and dive into JST NvDSPreprocess CPP. Here, the main part is to take a look at the two functions, JST NvDSPreprocess on frame and JST NvDSPreprocess on objects. So on objects, it will be useful for secondary inference, for example, when we will prepare tensors for each object. And on frame, it will be useful for transforming the whole frame. Let's take a look at the on-frame function. There will be a lot of code that are related to handling groups and regions of interest. If your use case is simpler, you can try to rewrite this function without those conditions, so it will be easier to debug. And then introduce those complexities later. Here, after we treated correctly regions of interest and group configuration, the interesting part will be to create batch, which is NvDS preprocess batch. And in this NvDS preprocess batch, there will be a memory that will be filled in by scale and field data. What we can do for custom preprocessing, we can use OpenCV or we can work directly with our GPU buffers. And the goal will be to correctly fill in frame memory pointer. After that, the special object that we are interested in is NvDS preprocess unit. And in NvDS preprocess unit, we will have to make sure to correctly add all the metadata and input surface parameter and our field in memory that will go to converted frame pointer. After that, the synchronous transformation function will take those converted frame pointers and transform them to the final version that we will feed to NvInfer that will respect RGB, BGR channels, and a number of channels and the order of channels. When you will modify this code, there is already a helper function that you can define dump rows, and that will help you to dump with OpenCV tensors that will be prepared by in default case scale and fill function, in your case with custom function, and you will be able to check those preprocessed images, which is very useful. When you get the correct implementation of tensor transformation function, make sure to add a probe and check that your NvDSPreprocess batch meta have correct object and is picked up by NvInfer. Also, you can drop the tensor from NvInfer by modifying a JST-infer code. So you make sure that on every preprocessing step, you really get what you wanted. After that, you'll be able to implement a more complicated custom preprocessing or preprocessing functions that potentially are different from your Python code because the default resizing function is implemented on GPU, and sometimes it generates some additional artifacts that you don't have in Python script. There is also additional example of DeepStream 3D action recognition that uses preprocessing plugin with a big custom library that batches regions of inference through time and then creates a special tensor for the infer. If this video helped you better understand NVIDIA's preprocess plugin, please subscribe to this channel. If you have any questions about NVIDIA's preprocessing plugin or DeepStream, don't hesitate to contact me through social media, YouTube, LinkedIn, or to write your questions directly in the comments down below. And I will see you in the next video.